Hello, I am from SP Academy. My name is Sham Pujar. Today we will solve some questions from NCERT textbook regarding circles. Today we are doing solving some questions regarding circles. I hope you understood everything which I taught you in the last class, the theorems and other things. So shall we start? Okay. So prove that the tangents drawn at the ends of a diameter are parallel to each other. Prove that the tangents drawn at the ends of the diameter of a circle are parallel to each other. So this is the question. This is question number 4 in your textbook. Exercise, I don't know. So this is my circle having a center at O. This is the circle which I have drawn. And my diameter is this. This is a diameter. What is a diameter? Diameter is the longest chord of a circle that passes through its center. Okay, and it is also equal to twice the radius. D is equal to 2r. So our requirement is to prove that the tangents drawn at the two ends here and here are parallel to each other. So let us try to prove this. So what do we write first? I will write what is given to me. Given. What is given to me? There is a circle. Circle with center at O is given to me. Let us say J and K is a diameter. So we'll write down that also. JK is and we have to draw two tangents now. Line L and line M. Line L and line M are the two tangents, one drawn at J and one drawn at K. L is at J. Similarly, M is a tangent to this circle at K. To prove, I am asked to prove that these two lines L and M are parallel to each other. Okay. So my proof starts. Knowing the properties of tangents and properties of circle, we are required to prove that L is parallel to M whenever two tangents are drawn at the two ends of a diameter of any circle. The two tangents shall be mutually parallel to each other. They will be parallel. So how do we prove now? Let us start. The proof starts. L is a tangent at J. This is given to me. So let me give some name to this. P, Q, R, and S. So PQ is perpendicular to KJ. PQ is perpendicular to KJ. I have to provide the reason for that, because a tangent is perpendicular to the line joining the point of contact with the center of the circle. This reason is very important. Always please provide the reason whenever you start a proof. Either it should be given in the problem, or for every statement that comes from your side, you have to give a backing statement, some backing, something to support your argument. So this is the theorem I am quoting to support my statement, this one. PQ is perpendicular to JK. So let me draw this line here. So this symbol indicates that PQ is perpendicular to JK. Similarly, second time when we repeat an exactly similar statement, we may not be required to give entire proof. So I'll say similarly, under the same lines, along the same line, we will also say similarly. RS is perpendicular to JK. RS is perpendicular to JK. Now observe these two. PQ is perpendicular to KJ. RS is perpendicular to JK. JK is a straight line. Since diameter is a straight line, JK is a straight line. And there are two lines that are perpendicular to one single straight line. Okay, please understand. Two lines are seen or observed by us that are perpendicular to the same line, which is JK or KJ, which happens to be the diameter. Hence, I will say that they are parallel. But what is the supporting statement I'll give? What should I say? How shall I back up my statement? So there is a small theorem which we studied earlier in previous grades. So we will quote that. Property of parallel lines. In that topic we have learnt earlier grades, may not be in 10th, that if these two interior angles are supplementary, or if these two angles, opposite interior angles, are equal, then the two lines are parallel. So one of the two we can take, any one. If you want to take these opposite angles like this, they must be equal. Or if you take this pair, they should be supplementary. Okay, so let us go by one of them. See, if you might remember, just to refresh your memory, we will do like this. JK is like a what? If L and M are two parallel lines, what do we call JK? Transversal. Okay, so there's a transversal line that is cutting two parallel lines. Here we don't know whether those two are parallel, but we know this transversal line is perpendicular to both of them. So we will make use of those angles. Let me say this angle and this angle. See, we have learned this earlier. If these two angles happen to be equal, and this is a transversal that is cutting any two lines, if it is seen and observed beyond any doubt that this angle is equal to this angle, we can say without any further confusion that the two lines are parallel. Same thing I am going to use here as I showed you, this and this like this. If these two angles are equal, then my lines L and M are parallel. They should be parallel. So we will make use of that. Hence, RS and PQ are perpendicular to the same line. The line L and M are perpendicular to the very same line, that is JK. And JK is our diameter. Hence, L and M are parallel to each other by the parallel lines theorem which we have studied earlier. Okay, you can quote either this opposite interior angle, or you can quote these two interior angles on the same side of the transversal. If they are supplementary, then also the two lines are parallel to each other. Is it understood? Have you understood clearly? Is it clear? Does anyone have a doubt? Shall I go ahead then? Hence, we can say that the two lines are parallel. Let this angle be 1, 2 and 3. And also by the property of parallel lines, we say that hence by the property, 1 minute, by the property of the parallel lines, we can say that the two lines are parallel to each other. Is it clear? Does anyone have any kind of doubt? If someone has not understood, you can always ask me any doubt if you have. Okay, shall we go to the next one? Are you sure everyone has understood? Next, let's go to the next one. It says, prove that the perpendicular at any point of contact to the tangent to a circle passes through the center. Prove that the perpendicular at the point of contact of the tangent to a circle passes through the center. Once again, draw a circle, mark the center, and then draw a tangent also. Then as it is asked, draw a perpendicular at the point of contact. Draw a perpendicular at the point of contact. We have to prove that it passes through the center of the circle. Okay. In the previous class, we have seen how we proved that this is the shortest distance from the center to the tangent, and hence the line joining the center of the circle with the point of contact is perpendicular to the tangent. Now we are asked to prove that this line, when we draw a perpendicular at the point of contact, it must pass through the center. Okay. So here we can quote that theorem which we have already done, and I must tell you, in that also there is no strong proof. We did not prove it directly, we just proved it by some other method. Okay. It was not straightforward proof like geometry proofs where we quote other theorems. So we proved it in a very simple way by deduction. So we will not do that here. We will now quote that as a theorem to prove this one. Okay. Since we know very well that whenever a tangent is drawn, the line joining the point of contact with the center is at right angles to that tangent. Okay, because if you draw any other line, all those lines are longer than this line because of the Pythagoras theorem. Because of the Pythagoras theorem, this square plus this square is equal to this square. Hence, this line will be longer. So, which will be the shortest line? The shortest distance is this. Hence, we deduced, we understood that yes, that is the shortest line, and from any point to any straight line, if you draw the shortest line, what angle will it make with that line? It makes an angle of 90 degrees. So we have learned this earlier. I hope you remember, in the last class we did this and we deduced it. Okay, so that now if you take this line, there is no this one, Pythagoras theorem. We don't have this, we just have this in case of this. So what happens? It has to be the shortest. It is the shortest. Hence, we know very well that the line joining the point of contact what do you mean by the point of contact exactly? It is the point where the tangent touches the circle. We know that the line joining the point of contact to the center to the center O. This is the line joining center O with the point of contact. It is at right angles to the tangent at that point. We know it very well. So now they are asking prove that the perpendicular at the point of contact always passes through the center of the circle. So this is the theorem that which has been already proved. We are going to quote this and say yes, my tangent at the point of contact and the perpendicular of that line of that tangent, the perpendicular drawn at that point, therefore always passes through the center. Okay, clear? Shall we go to the next one? Yes. Okay, now we are going to the next one. The length of a tangent from a point A at a distance of 5 cm from the center of a circle is 4 cm. Find the radius of the circle. Is this clear? Shall we move ahead? Okay. I read the question already. Question number 6. The length of a tangent. The length of a tangent from a point A at a distance of 5 cm from the center of a circle is 4 cm. Find the radius of the circle. This is the center. This is the center of the circle. And there is a point 5 cm away. 5 cm away from the center of the circle. And the tangent length is 4 cm. The length of the tangent is 4 cm. Whereas the distance is 5. Let us start giving them some names. This is O as usual. Center of the circle is O. Let this be A. And let this point be point of contact be B. Okay, so we have been given some data. What is given to us? We have been given that there is a circle with a center O. And AO is equal to 5 centimeter. BA or AB. To find. What do they want us to find? They want us to find the radius of the circle. Which is radius here? OB is the radius. OB is the radius. So we need to find what is OB. So we'll have a small construction here. What is that small construction? We will join OB. Join point of contact B to the center O. Join the point of contact B with the center of the circle O, we get a right angle triangle, that is ABO. ABO. Now how can we proceed? We have to find the length of it. Now this is 5, this is 4. Okay. Is the situation clear? Have you understood what is given in the problem and what we are supposed to find out? Okay. So now we have to find out OB. And we also know that it's a right angle triangle. But how is it a right triangle? Who told that it's a right triangle? How do we know it's a right triangle? Whenever a tangent is drawn to a circle, the tangent and the line joining the center to the point of contact make an angle of 90 degree. They are at right angles. They are always at 90 degree right angle. Hence, we find the angle ABO is equal to 90 degree, because we know the theorem. We are going to write it as a reason. AB is a tangent, OB line joining center to the point of contact. And hence ABO is 90 degree. This is a theorem which is well known. We all know about it. We have studied, we have proved it. Yes. Now what? How do we proceed? Yeah, it is 90 degree. We have learnt, we know it. And it's a right angle triangle. So we will apply Pythagoras theorem to find out the unknown in a right angle triangle. Hence, Pythagoras which is the hypotenuse in this? The side opposite to 90 degree is always the hypotenuse. AO square is equal to AB square plus BO square. AO square is equal to AB square plus BO square. Then, what are the things we know? Go back. Given, they have given us AO, they have given us AB. Can we find out BO? Yes, very easy. Okay. Check here, AO. AO is the hypotenuse 5 square is equal to AB 4 square plus BO square is equal to 25 square minus 16 square. 5 square is 25, 4 square is 16. So OB square is equal to 25 minus 16. Okay. So find out what is BO or OB. That is okay, everything is fine. BO square is 9, so BO is root of 9. Then why did I write plus 3? Because strictly speaking, in mathematics, when a number BO is equal to square root of 9, we should get two answers, plus 3 and minus 3. Can we accept minus 3 as the answer? No. Why? Can anyone tell me? Why minus 3 is not acceptable as the answer to this question? Can we have radius of a circle or length of a line as minus 3 centimeter? Does it make sense? No. Hence, we select the correct one. Yes, technically we always get two answers, plus 3 and minus 3 to this, but please reject minus 3. It is not of any use to us because we know very well that lengths of lines, lengths of anything or distances, their measurement cannot be in minus, they cannot be negative. There is nothing like distance between two places is minus 5 kilometer. No, it makes no sense. So we select plus 3. So what is this? Hence radius is equal to radius is equal to 3 centimeter. So this is how we solve this problem. Question number 6. We will next we will do 7 and 8. Let's take a short break.